Good morning. Pretty lights, pretty lights. Imagine how much difference it makes here in Sweden with just like half an hour in terms of, how much light there is. I tell people all the time that, if the Lord of the Rings movies, like if Frodo had been a Swede, it would have been a one movie, and he wouldn't even that whole deal with the darkness taking over him would never happen to a Swede. It would just be a gentle stroll back over to the volcano, and he would just throw in the ring, and that would have been the end of it. Anywho, that's not what I wanted to talk to you about. I wanted to talk to you about it's not necessarily the newest thing in the world. C# has been doing it for a little while, and it's the concept of extensions, which is what it's called in Swift, but in PHP, for example, it's called traits. And in essence what it is that you can declare an extension or a trait on a implementation class, or a class that has an implementation, and then you can extend, if you will, different methods, and in some cases even field variables on that class. Now, why would you do that? Some people actually argue that this is really dangerous and that you can mess a lot of stuff up, and to your point, I do absolutely agree with this. This could potentially be very dangerous, but I think there's a really, really strong and very nice use case for this in the language, and I think most languages should actually use this if you're going with an object-oriented approach. And not just necessarily that. There are other languages where it would make sense. I don't think it makes a lot of sense in JavaScript, but just hear me out. So one of the first things that I did when I started programming in school was that I, just as everybody else, learned the concept of encapsulation, because we were doing Java development, and as Java developers we do object-oriented programming, and you're very quickly taught encapsulation and the idea of creating classes and objects and all that good stuff. Now, the second thing you learn is to get a feel for how large an object, or a class should be, in terms of, in theory you could have a single object or a single class do absolutely everything in your system for the most part. And that is going to create what we call, or rather the term that was used where I was taught was God classes. And a God class is quite literally a class that has so many methods and field variables and stuff in it that it virtually does more than it should be doing, or in theory, it does everything right. Now, one of the fundamental problems that I've always argued when it comes to object-oriented programming, something that I don't think anybody really has had so far a really nice solution for, is that if you are mapping out your domain in a in a domain-driven fashion, which object-oriented programming does so well, it really feels, especially when you're starting out, it's so nice to be able to map out your entire application domain in classes. I really like that. And unfortunately, there are these objects or these domain concepts that are going to be natural code hubs. And what I mean about a code hub, it's basically a God class. If you have a large, take Ticketmaster. So they have a event object that represents an event which you can attend in the system, in an event, basically an artist coming to an event. Do you have any idea how big that class is? It's monstrous. Same thing with the payment object. Payments, there's so much stuff that class has to be able to do. And unfortunately, you can argue that, yeah, sure, we can use inheritance, and we could try to make some interface. You could, in theory, yes, you could try to do a lot of trickery to make this go away, but I mean, unfortunately, the monstrosity of the like the size of this class is inherently always going to be very, very large, because the concept and all the different logic that needs to take place in order for this to work has to be on that object in order for us to remain encapsulated, in order for us to still have this nice domain-driven approach to the problem. And this is where extensions really shine. That's why I really like them. So what I like to do with extensions is that whenever I have a namespace or a class or anything that really is a really holistic type of thing, I start thinking in terms of extensions, because although yes, the object becomes really massive, we can't really do so much about that, unfortunately. That's where the traits really shine, because now I can start thinking, okay, maybe I can create a directory where I put my class, that big, like the payment class, for example, I put it in a payment directory. And then I start thinking about at the feature level. So let's say that I needed to add a new feature, and that's going to add a lot of more logic into my payment class. Well, I'll break that out into an extension, name it, because usually when you deliver a new feature, it's usually by category, so that you name the extension file something that is semantically relevant to the group of functionality that you're going to create, and then you latch that on to the class. Now, what this will do is, in effect, it will allow you to keep around this single object that really well, like, fits your domain problem or your domain model really well, and it will at the same time allow you to keep your code more reasonable and easy to, or rather, it will be easier to reason about the code, because there's not a massive object of like 5,000 lines of code in the same file, right? Now, this is not a silver bullet. I think that there is a very, very good reason for like people being a little bit timid about extensions, because if you imagine that, like, there is absolutely a value in having everything in the same file, because if you start spreading out, like, because in essence, remember what you're in essence doing is that you're taking away, you're really only moving a bunch of methods and stuff from the file that you naturally, like the class, into a separate file that is still depending. Like, it's just moving code. It's still there. It's basically like folding lines of code, if you will, but putting them in a separate file. So I think that my personal rule of thumb for this is it's that, whenever I'm creating extensions and all of that stuff, be very careful about referencing internal, like, field variables and all of that stuff from inside your extended methods, because it gets messy if you're not careful. So, favor passing I think this is just a good rule in general, is when you're doing object-oriented programming. Just pass everything that you can humanly pass, even if it's a field variable. Always pass it. If you have no good reason for referencing a field variable from inside a class method, don't do it. Don't do it. Just don't. You will just make things more difficult on everybody else who's trying to use your class. So that's my rule. And my absolute favorite thing for using extensions is, one of my own projects, I have an integration, or I have several integrations, where I need to contact an API. So what I do is basically that I create a class called API, and because I have a lot of different endpoints that I need to contact in order to get my data, I can now create an extension for every request and latch that on to the API class. And all these are static methods. So it creates a very nice developer experience for me, at least, where, like, I know that any integration I need to, or any external request I'm going to do over the network, I can go API.get users or get products or whatever, and I can, in theory, grow that API namespace in, like, forever because of extensions. So check them out. Be careful, like, don't just, if you don't have a massive superclass, this like extensions, in my opinion, they don't make sense if you're not using them in order to just reduce, like think of them as a way of simply reducing the amount of lines of code in a class, and then group them based on features or group them based on functionality, and I think you're going to be good.